Welcome everyone to Nailing Your Thesis, our course on how to perform research. My name is Dirk Riele, I'm leading this course, and we are still at the beginning, and the next few slide decks and sessions will be about motivating research, why science is important, and then giving you plenty of examples to get a first feel for what science is about. Science is actually pretty prestigious, if you will. There are lots of ways of how society celebrates scientific breakthroughs, celebrates the people behind it, the researchers, the scientists. And the most prestigious award perhaps that signifies this is the Nobel Prize, traditionally being given to the classic sciences, like physics, and also some others with recent additions like the Peace Nobel Prize, not so much having a scientific as a political meaning to it. But in any case, this political meaning also attaches to the value and prestige of science, and hence you can see how our society significantly values what science stands for, which is, in general, the progress of society towards an ever better future. Computer science doesn't have a Nobel Prize, it's too young a discipline, so it invented its own, called the Turing Award, after A.M. Turing, the British scientist, groundbreaking computer scientist. And it's like the Nobel Prize for various disciplines. The Turing Award is being provided every year by the ACM, Professional Organization of Computer Scientists. Well, science, then what really is it? What might be the work that gets you any of these prestigious awards? Here a joke. See these mysterious carpet circles, one cat says to the other. Strangely, it continues, the couch has been abducted. Coincidence? I think not. Well, is that science? Well, it's some sort of investigation. Most people will say this is not science. If anything, scientific methods might be employed here as this riddle or mystery is being solved. But it's not really about groundbreaking, new discoveries, insights, or something which we'll get to know as theories being developed. So science then is developing and validating theories, where a theory is some model or explanation of the world, but science is not the use or application of those theories to solve a particular problem. If you're developing and validating a theory, you're chartering the unknown. If you're applying a theory, so the idea, you are already in known territory because there is that theory or model or framework that maps it out for you, and so you're just using that theory. This distinction is not always easy to make, but it is quite fundamental and also always a bit of a struggle for any discipline that is trying to build something new, like engineering. That also is then one way of looking at the difference between engineering research and engineering science, or the application of engineering during an engineer's workday, perhaps. Scientists build something, if they're engineering scientists, unlike social scientists or engineering scientists build something to learn, while engineering education leads you to learn how to build, and then during your professional days as an engineer, you might simply be building based on what you learned. Naturally, you'll continue your education, but the difference is that the purpose of building, in the first case, in the case of science, is to build something new, and of such a form that you can learn something about the world that you didn't quite know yet. While as a regular workday job as an engineer, you build something that typically has been mapped out, is somewhat understood, is not groundbreakingly new, has been done in similar forms. And again, this might of course be not always easy to distinguish. Here is XKCD on what writing code, performing engineering work might mean. If it actually is new and groundbreaking in academia, the currency, the compensation for your work will be research papers and maybe awards. While in business, it will be a pat on your shoulder for solving a particular problem, but business then does not care about any fundamental breakthrough. It only cares, so the idea here, about the specific progress at hand. Science values a general solution, a new theory, and business values fixing the problem at hand. Here you can see it illustrated. Science, that is the axes. That's the x-axis and the y-axis that help you understand this whole quadrant, so to speak, the overall territory, while business or everyday work in a job values getting from A to B. And once you reach B, that's fine. You don't care about the overall territory. Which of course is a simplification, because as business may want to repeat processes, it very much cares about understanding the overall territory. But it is science which charters the fundamentals first. So science is also fun. We talked about the Nobel Prize. Now you may be amused to hear that there's something called the Ignobel Prize, basically a spoof or a fun prize. It's real, it's a real event held every year in which a committee gives scientists, real scientists, an award, the Ig Nobel Prize, for research that makes people laugh and then think. So on the outset, that research looks like silly. Should this have been done? Why was money spent on performing this research? But then actually you think about it, that's the intention of this prize, and see the value or recognize something beyond the usual mode of thinking. So being displayed here, you see the 2011, I think, 2009 Ig Nobel Prize winner, a woman who invented a bra which can double as a gas mask. As you can see, she and most certainly the 3 old men around her are having lots of fun of trying it out. The Ig Nobel Prize is given every year. Here are a couple of more examples. The Veterinary Medicine Prize was provided to Catherine Douglas and Peter Rawlinson in 2009 for exploring stock managers' perceptions of the human-animal relationship on dairy farms and in association with milk production. So this is about how to make cows give more milk, and they found that if the farmers actually talk to their cows and give them names, the cows will give more milk. Seems worthy of the Ig Nobel Prize. So you laugh, or you may laugh, I don't know, but behind that was proper research or reasonable research, as is being exemplified by the reference, the research paper that made this work known to the public. That, as we can see, or we will see later, is a key aspect of research. You need to publish it, but once you've got it published in a reputable journal, in a reputable publication outlet, it does count as a contribution to the progress in science. It may still be shown later that it was faulty, but as long as this hasn't happened, it's considered a worthy contribution to science, and hence some people, certainly those in this domain here, thought this is good research. So what does that mean? So let's take a look at this example, as amusing as it may sound, and view it as serious research. Here is a rationalized, simplified research process We will look at the research process later and we'll find the complications in it, talk more about it in detail. But here is a simplified process that these researchers who investigated cow milk production may have gone through. They needed a motivation in the beginning, a so-called research question, possibly supported by research hypotheses. Then, in order to be able to say something about answer this question, they needed data, and data of such a sort that it supports their research argument or answering the question or answering yes or no to the hypotheses in there. Then once they identified what data they needed to figure out a way to get to that data, which means applying a research method. We will see that this is a huge part of science and one of the main challenges, to know a good research method and to be able to execute it well so that it will give you the data that actually helps you, lets you answer your initial question in a conclusive way. And at the end, they needed to write the paper, in this case, the paper that got them the Ignobel Prize. So here we are. The initial question was rather straightforward. How to increase output of milk cows? Fair enough. But it's too general. What is your answer to that? You can come up with so-called hypotheses, like naming cows and talking to them will increase their output. You could have had other alternative hypotheses or simply other hypotheses, and probably they had many hypotheses, like playing Mozart to cows will improve their output or increase the output, or celebrating Christmas with your cows in the stable, in the barn, will increase the output, things like that. Here, the specific hypothesis is naming cows will increase the output. With that, they needed to figure out an answer. Is that true? Is the hypothesis true or false? And so they needed to look at basically the argument to be made. They needed to show that if everything was identical between two sets of cows, so the argument here, cows who have names give more milk when compared to those with no names, not being named, not being talked to, give less milk. In there were a couple of professional terms like more milk. It sounds easy to the layman, but of course it needs to be precise. So they have a professional measure, the so-called heifer milk yield, which I assume somehow takes into account both the volume and the quality of the milk. And also in that research argument, we need to define what all other things being equal means, which is some sort of randomization so that no other factors interfere with the results. With this data to be gathered in a certain setup, if you will, they needed to decide on a research method which will give them this data, give them the data which shows them cows with more names give more milk, or does not show that. It's open what the result will be at the beginning of this research. There are many different research methods, some suitable, some not suitable. The way I talked about it, you may have thought, or you may be thinking that they probably used some sort of experiment. Actually, they did not. They chose survey research as the approach to getting to that data, meaning they created a questionnaire which they sent out to lots of dairy farms to gather data. And by going out to a large number of farms, they can claim that the results they gathered were representative for dairy farms. They got enough diversity that they could show generalizability of their work. And they do find, using statistical means from the results, that on farms where cows were called by name, the milk yield was higher than on those farms where they were not given a name. All right, fair enough. it's not, it's not research if it hasn't been published, so you just saw the research paper in which the results were shown. To continue with the Ignobel Prize, it's a lot of fun reading up over the years what prizes have been handed out. So here's the Ignobel Peace Prize of 2009, given to researchers who showed by experiment whether it's better to be smashed over the head with a full bottle of beer or with an empty bottle. I admit I don't quite know the societal value of knowing that, but I'm quite sure these researchers had a lot of fun doing their work. Or the physics prize, the Ig Nobel Physics Prize, on analytically determining why pregnant women don't tip over. I can imagine that some curiosity led to that, because it seems like a contradiction, as the center of gravity shifts within the female body while they are not raising the child, while they were laboring, well, not laboring quite. So basically having these first 9 months for that child, it shifts, and why wouldn't they fall over? So there must be adjustments in the body, and maybe we can learn something beyond that. Or the psychology prize for researchers who showed by experiment that people who think they are drunk also think they are attractive. Doesn't say anything about whether they are actually attractive, but hey, I think this is a phenomenon many may have noticed before. Also, apparently alcohol is an important part of the Ig Nobel Prize Committee's thinking on what makes prize-worthy research. Let's get a little bit more serious. Here is, we will show you now a video of an experiment, or it's actually a reenactment of a famous experiment, the so-called marshmallow experiment. In case the audio is not so good in the beginning, what you will see is a marshmallow being placed in front of kids, and the kids are being told that if they can withhold the desire to eat that marshmallow, then after a time period has lapsed, I think 10 minutes, they will be given a second marshmallow. And as you watch this video, try to see beyond the cute faces and the schadenfreude, if not sadistic feelings about those poor children being challenged like this. Try to think about what it is that is motivating this research work, and then we'll talk about it in a bit. So TA, can you please stop this video and show the marshmallow experiment? Thanks, I'll be back in a second. All right, we are back. You just saw this video. So let's review what you saw and then what it means. You saw these poor children being treated with a marshmallow that they were not allowed to eat. What you saw is a controlled experiment, but the motivation of the research question is not apparent right away. The research question you can see here, it asks, is the early ability to withhold instant gratification, meaning eat the marshmallow right away, for delayed higher gratification, meaning getting that second marshmallow and having a higher enjoyable experience later on, is that a predictor of later success in life? Being able to control your desires early in your childhood, is that a predictor of success later in life? So then, of this research, you only saw one part. You saw a measurement early on when these children were young, and the researchers needed to revisit them later in life to see whether, by whatever means, they were successful, more or less successful in life, and then correlate that to the results from this early measurement on the children's ability to withhold instant gratification. It is a an experiment, a controlled experiment with two main measurements, the early one and the later one. And as you can see, and it's been quite well cited and well known experiment, and what you saw again was a reenactment. So this constitutes the core of science, if you will, answering to hypotheses, the research question. So it's actually a hypothesis here, a very specific question that can be answered with yes or no, by way of a controlled experiment. Let's ignore for a bit how controlled it was, the details of this. And controlled experiments are perhaps the most classic, most well-known method of research that everyone will point to. If you're a research scientist, that's what you do. Interestingly enough, this particular experiment was not about particle physics, where sometimes most of our attention goes to physics. No, this was in psychology. And that actually is quite relevant to computer science and information systems, because humans are also a big part of the research we do. We often ask questions like, is this tool making us more productive? Is this method a better way of doing things? And it always has humans in the equation. So we need to use research methods to answer those questions, which are often related to methods from psychology and the social sciences. For the particular example at hand, there's an interesting question that might be in your mind. Let's assume that this correlation between early childhood ability to withstand desires for later gratification is a predictor of success in life, later success in life. Then can parents create more successful children, offspring, by training it to delay that gratification? Is this being answered by the experiment? Well, this is a deep question, because the experiment only showed, at least as well, we only saw some small part of it, but may only show the correlation, meaning this correlates statistically speaking, but it's not clear that this ability to withhold instant gratification is really the cause. If it's a well-done controlled experiment, it sorted out all the possibly confounding factors, and it's a very clear correlation. But whether it's also a causal relationship and there is no other unknown cause, that, of course, remains to be discussed. So then, this leads to an understanding of science where we perform so-called theory building by looking at reality, and then showing that these theories which explain the world are true by performing the appropriate research. This depiction of the cycle of science will be with us for the whole course. I will pick it up in a later lecture and discuss it in more detail there. You may now wonder, who may be a researcher? Well, everyone can be a researcher. There are no boundaries to entry. Science regulates itself by way of publications, but nobody stops you from writing a paper and submitting it. The reality, of course, is that it has lots of customs, lots of things, how you recognize the skilled researcher, and so if naively you try to publish a paper by first submitting it to a publication outlet, you may stumble because you're just not following known conventions and might get sorted out, rightfully or wrongly, might get sorted out. But at least in theory, we are all peers. It's a hierarchy-less society, supposedly. Nailing Your Thesis, our course, takes the following perspective. We are all practitioners. Reality is independent of us. We can look at reality and analyze it without influencing it too much directly. And then all of this takes place within the context of science, which we have to recognize is a social system with its various shortcomings and we will look at those as well. Viewed as a social system, the key components of science are peer review. Before you might get research work published, meaning accepted by peers as noteworthy results, you need to get those peers to say that, which is the so-called peer review. Other people will judge your work as much as they might ask you to judge someone's work. And if you pass peer review, you get your stuff published in a publication venue like a journal or a conference. There are various degrees of difficulty and hence also prestige of a publication. All of this is managed and embedded in professional societies, and behind or underlying all of that is actually quite some competition between research institutions and often expressed as rankings. Now, you may enjoy science. I hope you certainly will enjoy science. Doesn't mean that the job of a scientist is an easy one. Here you can see a tongue-in-cheek take at what it means to be a scientist then, or scientifically educated, and then society not needing your skills. So think hard about whether you are a scientist. Obviously, there is no questioning that you should get a scientifically founded education, but becoming a research scientist is yet another step beyond taking what you learn and applying it in business. I assume that many of you are taking this course for the purposes of writing a better final thesis, as well as getting an education for a potential career in science. But the first hurdle, of course, is your final thesis, and this course tries you to write how to do a better one. It's anchored in the degree program rules and regulations. They always talk about how your final thesis should be a scientific topic, how increasingly as you mature, you should not only be working on a scientific topic, but how you independently show some independence in working on it. That would be the master after the bachelor. And how a PhD means making a small, not necessarily small, but at a minimum small, but significant, non-trivial, that is, contribution to the progress of science. So bachelor and master means working on some scientific question, not necessarily making or creating significant progress yourself, but of a PhD, it's expected that you move our understanding of the world forward by a scientific contribution accepted by scientific peers. So that is what is expected of you in the different theses you might be writing, bachelor, master, or PhD thesis. And that is the challenge for you. If you would like to get into science beyond your bachelor or master thesis, we do recommend you participate in our colloquium, where you can see other students and sometimes guest speakers present research work. It's a good way of learning by example, and if you're a computer science student, that's where you have to do your final presentation on your thesis as well. So then what you learned in this slide deck is how science fits into the context of our society, how it relates to business and engineering. You got some examples of a basic research process and how it all fits together in your degree program fits with your final thesis to be written. Thank you very much, and I will see you in a bit.